All right, we're going to graph both of these functions on the same set of axes. So I'm going to do this one first. I can either plot points, or I can remember that 2 to the 0, or anything to the 0 is always going to be 1. So it's always going to go through this point, 0, 1. If I plug in a 1, I end up getting a 2, so that's going to be 1, 2. If I plug in a 2, you end up getting 2 squared, which is 4. So that goes up here. If I plug in a negative 1, 2 to the negative 1 is 1/2. F of negative 2 is actually going to be 2 to the negative 2, which is going to be 1 over 2 squared, which ends up being 1 over 4. And then it's going to be 1 over 8, 1 over 16. So there's going to be an asymptote here. So this will look like this. And the more points you plot, the better your graph's going to look. Now for this next one, this negative right here means that I am going to do since it's inside the house of x, I'm going to do a horizontal flip. So I'm going to do a flip over this axis right here. So pretty much what I'm going to do is I'm going to flip all of these points. If you look, it looks like exponential decay, which is really interesting because exponential decay means that this number needs to be less than 1. But if I do the definition of an actual negative exponent, if you remember, b to the negative 1 is the same thing as 1 over b. So 2 to the negative x is actually the same thing as 1/2 to the x. And the reason they have us plot these on the same axes is to show you the similarities between them. And 1/2 to the x is the same thing as 2 to the negative x, which means, yes, it's going to be a decay. And it's going to look exactly like this, only with a horizontal flip.